Hello. My name is Tamara Beal, and I work as an environmental educator here at Grafton Lakes State Park. Sorry for the slight delay. We had a couple of technical difficulties, as it always is. So today we will be doing a nature experiment, and specifically we'll be doing that about why ice floats. So over the next couple weeks, I'll be doing different nature experiments once a week. These nature experiments will be uploaded onto our Facebook page after our live video. So if you miss our live video, it's no big deal. It will be on our Facebook page under videos, and it will also be on our YouTube page. So you can find our videos later on either of those websites. And so today we have a bunch of different things going on. You can follow along at home if you have already prepped your stuff. If you haven't, you can always try this later by rewatching the video. So we have two different experiments I have prepped for. One is going to involve two glass beakers. You can also use glass, just glasses that you have at home. A plastic sheet, thin but also durable. Two food colorings. If you don't have red and blue, that's no big deal, but if you have red and blue, that would be great. And then you will also need hot water and cold water. So I have cold water, hot water, and that is for our experiment A. And then for our second experiment, I have this container with lukewarm water. You can leave it in overnight to try to make sure that it is room temperature water. If not, just try to get as close to as you can to lukewarm water. And then I have ice that I've previously dyed blue. And then we will have red hot water that you'll use for this too. So this is all you need for these two experiments. Now I do have gloves on, one to try to protect my hands a little bit from the really hot water, but also to try to protect my hands from food dye. I have dyed my hands way too many times doing things like this. But more specifically, to protect my hands from the really hot water, I have these extra thick gloves. So this was previously put on the water heater machine. It is very hot, so I do like to try to wear extra thick gloves. So we'll start off with experiment number one. Now remember, we're trying to figure out why ice floats. Specifically, we're starting with what happens when you combine cold water with hot water. So what we're going to do is we're going to try to identify that by having, using two different food dyes, one for hot and the other one for cold. So it's really arbitrary, but red for hot, blue for cold. So we're going to put a bunch of drips down in here. Doesn't really matter how many. And then a bunch of drips down in here. All right, so then I'm going to take the cold water, pour it in the blue. And when you do this, you want to fill it all the way to the top, to the point that is actually slightly over the top. So you want to have that, what's called a meniscus, where it's just over the top. And then we're going to do the same for the hot water. Now, you may notice that this table here is white. It's covered in paper, so this is a very messy experiment. You're likely to spill the water, and with food dye, it could possibly dye your table or whatever counter you're using, so make sure that you have covered it with newspaper or something like that. And then the hot. All right, so at this point, we have this plastic sheet. We're going to put it right over the hot. So first we're going to test if you put hot over cold water. When we put that on top, I'm going to pull the plastic sheet out, and we're going to see whether they mix. So you can kind of have your hypothesis, whether you think they do or not. So again, I'm going to put on those thicker gloves because this glass beaker right now is very hot. And then we're just going to slide it so it pretty much perfectly aligns. And then very carefully you want to slide this out. Pretty cool. So right now what we're seeing is we have perfectly red on top, perfectly blue on bottom. And you see this perfect line in between where these are not mixing at all. So red on top is hot, blue on bottom is cold. So the question is, why? So we're going to reverse it, put the hot on bottom and the blue on top and see if there's any difference. Put the hot on bottom, the cold on top. Maybe some of you already have guesses of what is going to happen. So to try to minimize the amount of mess, I'm going to dump these out. Don't try to flip it over. I've tried that. It just makes an entirely huge mess. So we're just going to bring it up over here. Dump them out. All right. And then we'll do this again. All right, so again, we're going to put some blue drops in the cold. I'm going to take these off so I can have better dexterity. Red drops in the hot container. Right. Fill up the cold. Right up to the tippy top. And then the same with the hot. All right. This time, we're going to put our plastic sheet over the cold blue water. All right, switch this one over. And make sure it's lined up as well as possible. Now, you can see here, red, hot on bottom, blue, cold on top. Let's see what happens. So it almost instantly starts to mix. So very different than when we had it the reverse with the hot on top and the cold on bottom. So in this case, if we had a thermal camera, you would see that not only have the colors mixed, but the temperatures have mixed and found about, a temperature kind of in between the cold and the hot. So not as hot as the hot originally was and not as cold as the cold was. Now this has to do with the density of water. So water is, when it gets hot, it is less dense. When it gets cold, it is more dense. Now we're going to do a second experiment to try to see that even more so, and we're going to continue to try to think, okay, cold water, less dense, sinks, hot water, more dense, floats, or rises, so why does ice float? It's kind of the opposite of what is going on here. So maybe we'll look at experiment number 2 and that will help us. So again, I'm going to pour this into here. I'm going to put one of these gloves on. All right. So experiment number 2, we have this container with room temperature water. If you want to make sure that it's room temperature, you can let it sit overnight. If you don't have that amount of time, you can just kind of approximate that it is about room temperature. And then we have our ice dyed blue. Now I did not give myself enough time, unfortunately, so these ice cubes could be better, but that's okay. We'll deal with it anyways. And then just switch that out a little bit. And then we need some hot water dyed red. So again, I'm going to put some red drops in here. And then put this hot water in. Now this one doesn't need to be filled to the top. Just wherever is good. So then we're going to take one of our ice cubes. Now if you're smart, you'll freeze them the night before, unlike me. All right, so I'm gonna put it. Now we're just gonna watch kind of what that cold water does. We'll put a few of them in here. So you may notice pretty quickly that cold water is sinking. Pretty quickly it's sinking. I'm not sure if you can see that really well with the camera, so I'm actually gonna show that off. Bring it up nice and close. All right, so we can see right here that the blue water is actually sinking down. And so that we can pretty easily tell that another example of cold water being more dense, sinking in this room temperature water. Now we're going to compare that to when you put hot water in it. I'm going to give this a little bit for it to do its thing. Now pretty quickly you may be noticing that all of the hot water, which is dyed red, is on top for the most part, and all of the cold water, which is blue, is on bottom. And there's actually a little bit of a clear layer in between of that lukewarm water. So you have the cold water on bottom, lukewarm water in the middle, hot water on top. So another perfect example of the density of water. So when we talk about water, we think about the molecular structure, which basically just means what is water made up of? So water is made up of H2O, 2 H's, and 1 oxygen. It makes a kind of V shape, kind of like this, the oxygen at top, and the 2 hydrogens coming off of the arms. Now, when water is, in its liquid state, in the water state, those molecules are moving around like this, and they're bumping into each other, and they're combining, and they're separating, and they're combining, and they're separating continuously as it is water. As the water increases, that energy goes up. So we talk about kinetic energy. So as the water temperature increases, that kinetic energy increases, and so those bumping into each other gets faster and faster and faster, and so the density gets less and less because there's more space in between the water molecules as it's getting warmer. Now what is combining those water molecules are hydrogen bonds. So those hydrogen bonds connect different water molecules, but hydrogen bonds are very weak. They're very weak bonds, even though they're very important bonds, but they're very weak. So as the temperature goes up, those hydrogen bonds cannot keep up with the movement, and it is just very unstable as it gets hotter and hotter and hotter until it becomes steam, and then things are really spread out. Now compare that as it starts to get colder. That kinetic energy starts to get less and less, and there's not as much movement. There's more hydrogen bond connection going on. And actually, when it gets down to the point of about 4 degrees Celsius, there's very little movement. And so that can be demonstrated here with the hot water mostly on top, the cold water mostly on bottom. So you would think that, well, the colder things get, the farther and farther and farther down it would sink. Well, that's true up until about 4 degrees. So water is actually heaviest at 4 degrees Celsius. That is when kinetic energy and hydrogen bonds cross paths on a graph. That amount of energy in those two things is equal. And so there's very little amount of movement. Everything is very condensed, close together. But then when you drop below that, that's when interesting things start to happen. Because again, you would think, okay, below 4 degrees, you would have even more, water sinking down lower. But in fact, ice floats. It doesn't sink, it floats, which is counterintuitive to everything that we've been learning today about temperature and molecular density and all of that. So what happens when ice goes below, or water goes below 4 degrees, is those hydrogen bonds start to match up. And they match up, and they match up, and they match up. It's because the hydrogen bond energy is now higher than the kinetic energy of the molecules. So these hydrogen bonds that have been trying to form this entire time are finally able to hold on and make those connections. And so what happens is those connections form until you get a nice hexagonal shape. And that shape is the reason that ice floats. Without that shape, ice would not float. You would not have life as we know it, in fact. Because when that shape forms, it creates an air bubble in the middle. So that air bubble in the middle is what allows ice to float up and exist on the top. So in our park, we have 6 different ponds. And we're known as Grafton Lakes State Park. We have 6 different ponds. In the winter, these ponds are known for ice skating, for ice fishing. It's one of the best things that you can do during this time of the year is get outside and enjoy what this park has to offer. And the whole reason we have that is because of this weird property of water. It's weird because there's no other compound like it. Most other compounds, when they get colder, they follow the same suit as water, but they continue to sink. They continue to sink. Cold things, and especially when you get to a solid, sink in the liquid form of the compound. But in the case of water, ice floats in water. And if this wasn't so, you wouldn't have life as we know it. Because if you go way back in history to ancient history, prehistoric times, all life existed underwater. So if ice sank in water, fish wouldn't be able to exist. And if fish weren't able to exist, then the ancestors of fish, which moved onto land, and then which eventually, declared inalienable rights and walked on 2 feet, aka us, wouldn't be a thing. So the fact that ice floats is not only, nice for ice fishing and nice for ice skating and just nice for having iced tea in the summer, but it's also amazing property that allows life to exist. So thank you guys so much for joining me today. Like I said, these videos will be posted on our Facebook page and on our YouTube page afterwards. And there will be another segment of nature experiments next Thursday. So it's not on Wednesday next week, it's on Thursday at 3 p.m. again. And we will announce what the topic of that experiment will be when it gets closer to that date. So thank you, and I'll see you next time.